.75 kilogram sphere is released from rest and is moving 5 meters per second after falling 2 meters in the viscous medium. How much work is done by the viscous force on the block? The sphere, I guess we.
What's the mass of it again?
0.75 kilograms.
Okay. Okay.
Yeah. It's falling 2 meters. Moving 5 meters a second.
Okay, and as I said, it goes 5 meters
Per second?
the whole time.
Yeah. From rest.
Oh, okay. Right. So it's moving, it's not moving at all. It drops into this medium, and at the bottom, comes out going 5 meters per second. So as it's falling, what's this viscous medium doing?
Pushing up.
Yeah. So as it's going, the whole time you've got some force. Pushing on the block. And how much work is done. Okay.
This sounds like we're going to have to find the whole area under a curve, right?
It would be the area under a curve,
The total.
but we're not given a curve, right? So we're not going to worry about finding
We don't have to make a curve.
But what's our equation that we were talking about with the conservation of energy and work? So we used to have this. Right?
Yeah.
But now what do we add for the work?
But I thought the second K initial was fine.
Oh, sorry.
What did we What'd you
So what did we add to this equation in this
Work.
chapter? Yeah. So we just said, okay, here's plus the work. Well, what's doing the work in this situation?
The viscous liquid.
Okay. So let's call this work of the liquid. And what are we looking for?
The work that it did to keep the ball from dropping faster, I guess.
So that's what we're looking for, right?
Yeah.
So can we plug everything else into that equation?
Yeah.
Yeah. So let's do that. So how much kinetic energy does it have at the top?
0.
How much potential energy?
Potential energy, the equation, would be 0.75 times gravity times 2
Okay.
meters.
And then work is what we're looking for.
Yeah.
What's the kinetic energy when it falls out the bottom?
Would be 10, right? The kinetic, would just be 5.
That's the velocity. What's the equation for kinetic energy?
Oh yeah, 1/2 times mass times a volume, velocity squared.
Okay. And then how much kinetic energy does it have when it comes out the bottom?
0.
Right. Alright. So then we can just solve for this, right? 25 is 0.75. That's 4.5. 6.25. Oh, yeah, no, that makes sense.
I get 5.325.
And is there a sign on that?
Negative.
Yeah. Yeah, so why is the work negative?
Well, I mean, it's still accelerating down, the ball is.
Yeah, we're not too worried about acceleration. So which direction does the force point?
Up,
Which way is the ball moving?
down.
So this is your force, this is your distance, right?
Yeah. And I mean, because it's still moving down, that would mean that the distance has to be greater than the force.
Yeah, but the idea is that the force and the distance are pointing opposite directions.
The direction of the distance, okay.
So work is negative, right? Or the other way you can think about it is, what is this liquid doing? Is it adding energy or is it taking energy away?
Taking energy away.
Right. So over on this side, it would be negative. So you'd have kinetic initial plus U initial minus work of the liquid equals kinetic final plus U final. So you know it's negative because it's taking energy out of the system rather than adding it into it. Okay?